So we'll talk about like one or two, three such algorithms as well. Like one of the algorithm that is available, we can talk about like a breadth first search. To be frank, the breadth first search algorithm is designed for the graph. And if this algorithm is designed for the graph, you can definitely use it with graph, not an issue. But since a tree is a kind of a special type of graph, tree can also be considered a special type of graph. The breadth first search and depth first search algorithm can also be used for the trees. So these are kind of a searching algorithms. These are kind of a searching algorithms. So what I will do is that we'll go ahead, we'll talk about two, three searching algorithms. First, we'll talk about like a breadth first search, one. We'll talk about depth first search, second. We'll talk about even binary search, because the tree what we discussed was basically the binary search tree. And the binary search tree, why it is binary search tree? Because it is saying that the searching is getting faster. And if you are saying that the searching is getting faster, so how exactly the binary search mechanism is going to work? And once we understand even binary search, then probably we can go ahead and we can talk about how we can delete the node, how we can delete a node from the tree. Let us just see one by one, step by step. The very first, I'll start with the algorithm, something called a breadth first search, BFS or breadth first search algorithm. फुल फॉर्म लिखता हूँ यहाँ पर, breadth first search. Okay, so what this breadth first search algorithm is all about? Breadth first search algorithm is also referred as level wise searching. It is also level by level search algorithm. So what do you mean level by level search algorithm? If you want to find the element, I'm saying that you first check at the level 1. If the element is not found there, you check it at the level 2. And if element is still not found there, you check it at the level 3. And if it is still not found, you check it at the level 4. तो जो आपका सर्च ऑर्डर है, that search order you are going level by level. जब आप लोग search order you are going level by level, then it is referred as level wise search algorithm. So what basically this level wise search is all about? Let us think of doing it. Please note that to implement now this algorithm, there is not much choice. इसको recursion से कर भी नहीं सकते. This has to be implemented in a non-recursive fashion. This algorithm is non-recursive fashion because for implementation of this algorithm, you will need queue. You don't need stack for this. You will need the queue. So queue आपको पता है एक end से add करना है, एक end से delete करना है. First in first out kind of structure. Yes, we need that. Let us continue further. तो सर हम लोग इसको कैसे यूज करेंगे? So you start with, I'm saying that you begin your algorithm by pushing the first element into the queue. See, this algorithm is very simple. ये जो पहले वाले दो थे ये ज्यादा डिफिकल्ट थे, ये उससे भी ज्यादा सिंपल है. Just pay attention. Start by pushing the first element root onto the queue, and you begin. What is to be done? What is to be done? Pop the element, pop the element, compare the element, pop the element, compare the element, and then put both of its child onto the queue. Put both of the child onto the queue. जो भी एलिमेंट आपको सर्च करना है, लेट्स से फॉर एग्जांपल आई वांट टू सर्च 80. अगर आपको 80 सर्च करना है तो मैं कह रहा हूं कि आपको 80 के साथ कंपेयर करो. बट इफ इट इज नॉट मैचिंग, देन उसके जितने दोनों चाइल्ड है, इन दोनों चाइल्ड को क्यू के ऊपर डाल दो. Okay, you put 30 and 90. You put 30 and 90 and repeat the process. Again, if queue is not empty, go ahead, pop one, pop one, check. Is it matching 80? Not matching. If it is not matching, put both of its child into the queue. Both of its child into the queue. Done. And repeat the algorithm. Repeat the algorithm. Again, you continue further. If queue is not empty, you pop the next element. You pop the next. You pop the next element, and then the next element. Is it matching 80? Sorry, this is also not matching 80. So put both of its child onto the queue. You find it is very simple algorithm. 70 and 100. Put it onto the queue. And you continue the story further. You pop the next element 10. Is it matching 80? सॉरी इट इज नॉट मैचिंग 80, पुट बोथ ऑफ इट चाइल्ड, लेकिन इसका एक चाइल्ड है ही नहीं, तो जितना है उतना पुश कर दो ना. About the next child is 20, you put 20 into the queue and you continue the algorithm. You continue the algorithm. Again queue is not empty. Pop the next element. Oh, I find 40. 40. 40 is it matching 80? Not matching. लेकिन good thing is that इसका एक भी child नहीं है. एक भी child नहीं है तो nothing to push. You continue further. You continue further. You pop the next element. Next element 70. Is it matching 80? No, it is not matching 80. What is to be done? What is to be done? It's both child. It's both child. I guess 60 and 80 is to be put into the queue. Okay, that is good. A 60 and 80, we have put it onto the queue. You continue the process. You continue the process. You pop. Hey, is it matching 80? Sorry, even this is not matching 80. If this is not matching 80, continue. If the queue is not empty, you pop the next element. You pop the next element. Oh, it is 20. Is it matching 80? Sorry, it is not matching 80, but इसका कोई चाइल्ड नहीं है. Continue further. Is it matching 80? No, इसका भी कोई चाइल्ड नहीं है. Is it matching 80? Yes, this is matching 80 and the element is found. Have you noted that जो element search हो रहा है, कैसे search हो रहा है? पहले level 1, then level 2, then level 3 and then level 4. तो level wise आपके element search हो रहे हैं, and that is the reason the algorithm is said to be breadth first search algorithm. You find that algorithm is was super simple algorithm. What was the algorithm? The algorithm start by pushing q dot push. It begin by pushing root onto the queue, and after that जब तक आपका queue empty नहीं हो जाता तब तक queue is not empty. जब तक queue is not empty, what do you want to do? What do you want to do? You want to pop one element. Trav is equal to q dot, you can say, let's say pop, and you want to match if the element that you are searching, is it matching with the trav? If it is matching with the trav, probably you want to return that trav. But if it is not matching, उसके जो दोनों child है, that you want to put it into the queue. So you simply say that if travs dot left is not equal to null, not equal to null, what is to be done? Push it onto the queue, push it onto the queue, travs left, or if if it has got right child, if right is not equal to null, go ahead, q dot push trav dot right onto the queue. This is done and it's over. It's over. So you find that such a simple, such a straightforward algorithm that you need to follow. Should I repeat this algorithm once again? Yes, no problem. I'm repeating it once again. Please pay attention. Let us do it once again. As I said that algorithm code आपके सामने है. Code आपके सामने है. Go ahead, take a look at that. Take a look at this, and if possible, you also do the paperwork with me. यहाँ पर हम लोग क्या कर रहे हैं? अब since it is searching algorithm, have a look at this. Since it is searching algorithm, we are trying to search. We are not trying to print. अगर आपको print करना है तो आप लोग print भी कर सकते हो. Choice is yours. I cannot stop you. It is up to you. But I'm just trying to tell you that हम लोग यहाँ पर element search कर रहे हैं. If it is matching, then we are just returning a pointer. सर मान लो अगर element मिला ही नहीं, तो अगर आपको कोई element मिलता ही नहीं है, तो at the end you can always return null, indicating that the element is not found. Don't worry, I'm just going through that. Please pay attention. Pay attention from where you begin with. You begin with by pushing 50 into the queue. A root is 50, so 50 को queue पर डालो, and then you start the algorithm. You start the algorithm. Now you find that queue is not empty. If queue is not empty, you want to pop the element. You want to pop the element, and you want to compare that. You want to compare, is it matching the element that you are searching? अगर आप लोग 50 ही ढूंढ रहे हो तो कुछ करने की जरूरत ही नहीं है. So you got it like a first place itself, and then you can return. But let's say that मैंने जानबूझ के मैं 80 ले रहा हूँ so that you see the whole all iterations of it. अगर आप लोग 70 लोगे तो शायद जल्दी मिल जाएगा, 30 लोगे तो और जल्दी मिल जाएगा. लेवल वाइज जो लेवल में सबसे एंड में रहेगा, obviously it will take the maximum iterations, and that is the reason I'm considering that let me find out 80. so that we can go through the whole algorithm. Let us begin. So, एक minute. So we got 50, and that 50 we are printed. चलो 50 is printed. Now what we need to do? Oh, we need to traverse. We need to. Q is not empty. So let us pop the next element. Oh, let us pop the next element. What is the next element? Oh, next element is a trav. A trav को pop करो, trav को pop करो और trav को compare करो. trav को pop करो, trav को compare करो. Compare कर लिया. अब उसके लेफ्ट में अगर कोई चाइल्ड है तो उसको क्यू में डालो. अगर राइट में कोई चाइल्ड है तो उसको क्यू में डालो. ए लेफ्ट का चाइल्ड, राइट का चाइल्ड चेक कर लो. ए लेफ्ट चाइल्ड इज 30, put it into the queue. Right child is 90, put it into the queue, and then you repeat the process. If queue is not empty, if queue is not empty, go ahead, pop the next element. A next element that looks 30, so you are popping 30, you are popping 30, so trav is at 30 now. You compare, is it matching 80? Sorry, it is not matching 80. If it is not matching 80, उसके trav के जो left और right है उनको क्यू के ऊपर डालो. ए trav के left और right, take a look at the diagram. Trav के left or right, I see 10 and 40. Yes, 10 and 40. Go ahead, put it into the queue. Put it into the queue, and you again go back. While queue is not empty. Oh yes, while queue is not empty, you continue further. Trav is equal to q dot pop. Pop the next element. Oh, next element is 90. Let us pop 90. Let us not pop 90. Is it matching 80? Sorry, it is not matching 80. It is not matching 80. What is to be done? Okay, its left child and its right child. Its left child and its right child, put it into the queue. Which are the left and right child? Yes, I see 70 and 100. It is left and right child. Put it into the queue. Okay, that done. And you again continue. I still find that queue is still not empty. Go ahead, pop the next element. One next element is 10. Let me pop it. So trav is over here. Is it matching? Sorry, it is not matching. If it is not matching, तो फिर उसका लेफ्ट अगर है तो ये अच्छी बात है. इसका लेफ्ट नहीं है तो छोड़ दो. लेकिन उसका राइट है तो पुट इट इनटू द क्यू. प्लीज नोट, इसका लेफ्ट नहीं है, इसका लेफ्ट नहीं है, स्किप दैट. इसका राइट है, पुट इट इनटू द क्यू. You continue further. You continue further. A queue is still not empty. Queue is still not empty. Pop the next element. Next element. Oh, it is 40 is there. Pop 40. Pop 40. And once you pop 40, check. Is it matching 80? Sorry, it is not matching 80. What is to be done? अब उसका left और उसका right. I find that ना तो उसका left है ना तो उसका right है, कुछ भी नहीं है, तो nothing to push. You continue further. Again I find that queue is still not empty, and since queue is still not empty, go ahead and pop the next element. Or next element that I see is 70. Next element is 70. You pop 70. Good. And then you compare, is this matching 80? Sorry, it is not matching 80. So its left and its right, put it into the queue. Its left is 60, its right is 80. Let us put it into the queue. Okay, that is going good. That is going good. And then again you check, while queue is not empty. Oh, not queue is not empty. You go ahead, trav is equal to q dot pop. Or q dot pop, the topmost element that we are popping is, let's say, 100. This is 100, and 100 is popped. Is it matching 80 or not really? This is not matching 80. तो उसका लेफ्ट चाइल्ड नहीं है, उसका राइट चाइल्ड नहीं है. Q is still not empty. Go ahead, pop the next element. On next element, 20 is popped. A 20 is popped, and you check, oh, is this matching? Sorry, this is not matching. It is not matching. उसका लेफ्ट 20 का लेफ्ट नहीं है, 20 का राइट नहीं है. You continue further. Q is still not empty. Go ahead, pop the next element. Pop the next element, like say 60. 60. You pop 60. Good. You compare. Is it matching 80? Sorry, it is not matching 80. 60 का लेफ्ट साइड नहीं है, 60 is right child नहीं है. Q is still not empty. Pop the next element. Next element you popped 80. Next element you popped 80. Is it matching? Oh yes, it is matching. If it is matching, the node pointer you can return. Let's say for example, if you are searching let's say 200, अगर 200 होता तो क्या हो जाता? ये 200 होता तो शायद ये भी मैच नहीं होता, ये भी मैच नहीं होता, और फिर आप लोग पूरा इस क्यू से ही बाहर आ जाते। और अगर क्यू से बाहर आते तो यू कुड हैव रिटर्न नल, अगर आप लोग 200 ढूंढ रहे होते तो, इन दैट केस, राइट? सो आई होप now the algorithm is clear. Breadth first search algorithm. Okay, so let us just quickly go back and implement breadth first search. पहले breadth first search and depth first search is in a copy paste of it. So let us just see. Let us implement it one by one. The breadth first search algorithm for searching, for the searching, and what we are returning? Oh, we are returning null. By the way, what is the time complexity? What is the time complexity? Now, to be frank, you are going through all the nodes one by one. We are going through all the nodes one by one. We are going through all the nodes one by one. So it is simply O of n time complexity. Obviously, luckily, अगर आपको पहले ही मिल गया तो बात अलग है. But that is kind of a best case or worst case that you can talk about. Anyway, so रुको. पॉप का कंडीशन इज नॉट क्लियर. प्लीज नोट. एक कोई तो पूछ रहा है पॉप का कंडीशन क्लियर नहीं हो रहा है. पॉप में कोई कंडीशन ही नहीं है. हैव अ लुक एट दिस. इफ क्यू इज नॉट एम्प्टी, क्यू के अंदर अगर एलिमेंट है, अगर कोई भी एलिमेंट है तो सीधा पॉप करो. कोई एक्स्ट्रा कंडीशन आपको अप्लाई नहीं करना. आई होप यू गॉट. यहाँ पर कोई इफ एल्स हम लोग कुछ लगा ही नहीं रहे. दैट्स द रीजन आई एम सेइंग दैट दिस एल्गोरिथम इज इजियर देन द प्री ऑर्डर एंड इन ऑर्डर दैट यू हैव लर्न अर्लियर. यहाँ पर कोई कंडीशन नहीं है. इफ क्यू के अंदर एलिमेंट है, उसको निकालो, उसको कंपेयर करो, उसका लेफ्ट चाइल्ड राइट चाइल्ड क्यू में डालो एंड रिपीट द एल्गोरिथम. दैट इज द ओनली थिंग दैट एल्गोरिथम हैज गॉट. इज दैट ओके? If we take 50, if we take 50, what is the problem then? क्या हुआ एकांश? If you take 50, what will happen? You are first pushing 50. We are first pushing 50. Then Q is not empty, so we are popping 50. And if you are popping 50, then you will find the element in a first iteration itself, and then you are returning address of the 50. That's it. I hope it is very clear. हमारा अल्गोरिथम जो शुरू हो रहा है, हमारा अल्गोरिथम रूट को पुश करने से शुरू हो रहा है. तो सबसे पहले जो हम लोग क्यू में डाल रहे हैं, सबसे पहले हम लोग 50 को ही क्यू के अंदर डाल रहे हैं. सबसे पहले हम लोग 50 को ही क्यू के अंदर डाल रहे हैं. सो ऑब्वियसली क्यू इज नॉट एम्प्टी, वी आर पॉपिंग 50 एंड देन वी आर कंपेयरिंग. सो अगर आपको 50 सर्च करना है तो विद इन अ सिंगल इटरेशन यू आर गोइंग टू फाइंड इट. इट इज काइंड ऑफ बेस्ट केस. आई होप दैट इज फाइन एकांश. राइट, हम लोग कहां पर थे? लेट्स कंटिन्यू फर्दर. एंड आई एम सेइंग दैट पब्लिक. वैसे अभी मैं यहाँ पर नोड रिटर्न कर रहा हूँ. To be frank, returning a node is not really a good practice, but still I just want to keep it simple. And the key to be search, I'm passing it over here. And let us repeat the algorithm. Let us go with the algorithm. It is queue, a queue of node that we want to create it. Queue of node, queue is equal to new. Queue से inherited, वैसे dq वगैरह भी classes है. I'll prefer a simple class linked list. अगर आपको पता नहीं है, check the documentation. Linked list is inherited from list interface, I know, but linked list is also interface inherited from the queue interface. आप लोग documentation एक बार check कर सकते हो. Linked list is also inherited from the queue interface, like a simple straightforward queue that you are making. And you begin the algorithm by pushing a pushing. बट यहाँ पर push का function नहीं है. मैंने शायद उस दिन आपको बताया था, यहाँ पर push और pop के function के नाम क्या है queue interface में? Yes, it is offer. It is offer. You can push root into the queue, and your algorithm begins. Your algorithm begins, and you're saying that by the time queue is not empty, you go ahead, you pop the element, a queue dot pop. अरे वैसे यहाँ पर pop भी नहीं है, but pop के corresponding, yes, we have got a poll function, and I'm checking if key is equal to trav dot data. If it is matching, I can simply say return trav. But if it is not matching, तो फिर उसका left होगा, a trav dot left is not equal to null, then put it into the queue. I put it into the queue trav dot left, and if trav dot right is not equal to null, put that into the queue trav dot right. This is done. Over. At the end, you can simply say return null. It's over. Nothing extra. We need to do it. That is what your breadth first search algorithm is all about. You want to cross check? Is it working, not working, or whatever? Let me just go ahead and let me take a value to be searched from the user. System.println. नहीं, स्कैनर चाहिए मुझको. पहले स्कैनर, स्कैनर sc is equal to new system.in. Okay, that is good. And then I'm saying enter element to find. Element to find. Let me take the value sc.nextInt. I found the value, and let us check. Hey, what is to be done? What is to be done? I need to simply make a call t dot breadth first search. You pass the value to be searched, and after that it is going to return you pointer to the node, and I can check it over here. By the way, node, wait for a minute. अब ये node मुझको मैं class के बाहर access कर रहा हूँ, कोई बात नहीं. So I need to access this node, and I want to check if temp is temp is equal to null. If temp is equal to null, what is the meaning of this? Temp is equal to null. What is the meaning of this? It simply means that the element that you are searching is not found. Correct? Not found. And otherwise I can try to find out that element found. And if you want to print it, you may print it once again. So simply saying that temp dot data. Obviously data is a private member, and the private member will not be directly accessible into the main class. Please note, private member and private member will not be accessible into the main class. I know, I understand, I guess you also understand that. I just quickly want to put one getter part for that. All right. Just to confirm that you can get the data and you can print it. Okay, right click, run as Java application. And you find that element to find. Okay, I tried, let's say 90. ये जो second level पे था, yes, it is saying that 90 is found. You run it once again. Not 90. Let us say I try to find a 70. 70, which was at the third level. Yes, that is also found. And you continue further. Let's say 80, which was like a last level. Even that is also found. As Ekansh was asking, so what about 50? Don't worry. Even 50 is found, not at all a problem. And you try to search something 200, which is not existing, which is simply saying that it is not found. I guess it is working. Please try it. Check if it is working. Let me know if you are facing any problem. Go ahead, copy paste, run it, check the output if it is going well. Breadth first search. The algorithm that we were trying is was a breadth first search. I hope this algorithm was simple as compared to the pre-order and in-order non-recursive. यहाँ पे ज़्यादा दिमाग नहीं लगाना था. It was like very simple. Just root से शुरू करो and follow that. correct? And wait, हाँ रुको जरा, Vishaka is saying something, रुको जरा. I did with int return type and return found element 0. Is it okay? Yes, that is also okay. See, now it depends कि आपको exactly क्या करना है. Like for example, अगर आप लोगों ने जावा कलेक्शन पढ़ा है, जावा के कलेक्शन में लिस्ट में दो सर्चिंग के फंक्शंस हैं. एक सर्चिंग का फंक्शन है इंडेक्स ऑफ फंक्शन. इंडेक्स ऑफ फंक्शन आपको रिटर्न करता है इंडेक्स ऑफ दैट एलिमेंट, और जो दूसरा फंक्शन है वो कंटेंस फंक्शन है. सो कंटेंस फंक्शन आपको रिटर्न कुछ नहीं करता, वो सिर्फ आपको बताता है ट्रू और फॉल्स, वेदर इट इज फाउंड वेदर इट इज नॉट फाउंड. सो इट डिपेंड्स ऑन योर रिक्वायरमेंट कि सर मुझको सिर्फ ये जानना है कि एलिमेंट है या नहीं है, तो यू मे गो फॉर रिटर्निंग अ बुलियन वैल्यू. नहीं नहीं सर, आई वांट अ पॉइंटर टू दैट नोड, मुझको उसके अंदर का डेटा चाहिए. अभी तो हमारा तो डेटा तो बहुत सिंपल वाला डेटा है, लेकिन इन फ्यूचर यू से दैट आई एम क्रिएटिंग अ ट्री ऑफ स्टूडेंट ऑब्जेक्ट्स, I am creating a tree of employee objects. And if you're creating a tree of employee object, so for a given employee ID, I want to get the whole data of the employee struct. If you want to get the whole data of the employee, at that time returning only boolean may not be sufficient. Correct? So it depends on the requirement, I'm saying. अभी के लिए as long as algorithm remains same, whatever you are done, that is also fair.